What's up, Facts Discoveries fam? And welcome back to the channel where we dive deep into the stuff you've always been curious about. Alright, let's get right into it. Have you ever looked at a condom and thought, man, this little thing is everywhere. It's in our health classes, our pop culture, our bedside tables. It's so simple, yet it carries this massive weight, playing a huge role in global health, family planning, and just, modern relationships. How does something so thin and stretchy get made to be so reliable? Well, today we're pulling back the curtain on the surprisingly complex and fascinating world of condom manufacturing. You think you know how they're made? Trust me, there's way more to it than you think. Stick around, because this journey is wild. So, let's start at the very beginning. The main ingredient for most condoms today is natural rubber latex. And no, it doesn't just magically appear in a factory. It all starts in nature, specifically with the Hevea brasiliensis, or as it's more commonly known, the rubber tree. These trees are primarily grown in Southeast Asia, in countries like Thailand, Malaysia, and Indonesia. Workers, called tappers, make precise cuts into the bark of the tree, a process that doesn't harm the tree itself. A milky white liquid, which is the latex, then oozes out and is collected in cups. It's a lot like tapping a maple tree for syrup, but instead of pancakes, you're on the path to making something that prevents unwanted pregnancies and STIs. Pretty cool, right? This raw latex is basically nature's goo. It's collected in large vats, and then it needs to be processed pretty quickly, because just like milk, it can spoil. It's rushed to a processing plant where it's first filtered to remove any impurities, like bits of bark, leaves, or dirt. Think of it like making a super smooth smoothie. You don't want any lumps in the final product. After filtering, the latex is put into centrifuges. These machines spin at super high speeds to separate the rubber particles from the water and other stuff, concentrating the latex to make it stronger and more stable. They also add some chemicals like ammonia to keep it from solidifying too early. This isn't just a casual mix-on-go process. It's a science. The consistency has to be perfect. Once this concentrated latex arrives at the condom factory, the real fun begins. It's stored in massive temperature-controlled tanks. The factory's kitchen is where the magic recipe comes together. This isn't just pure latex they're using. They mix in a secret blend of chemicals, a process called compounding. These additives include vulcanizing agents like sulfur, which make the rubber strong and elastic. This is the same basic process that makes car tires tough. They also add accelerators to speed up the vulcanization, antioxidants to prevent the rubber from breaking down over time, and stabilizers to keep the mixture just right. Every company has its own proprietary formula, a secret sauce that determines the final feel, strength, and shelf life of the condom. Now, we get to the part where the condoms actually take shape. The factory floor is lined with these long, continuous production lines. And on these lines are hundreds, sometimes thousands, of glass or ceramic formulas. These are essentially penis-shaped molds that are moving along a conveyor belt. The formers are meticulously cleaned and prepped before their big dip. The entire line then dips the formers into the vat of compounded latex. The speed and duration of the dip are super controlled. Too fast, and the condom is too thin; too slow, and it's too thick. It's all about hitting that sweet spot for a perfect uniform layer of latex. After the first dip, the formers are slowly rotated as they lift out to ensure the latex does undrip and create weak spots. But one dip isn't enough. The formers, now coated in a thin film of latex, travel through a drying oven. This initial drying helps the latex set. Then they often go for a second dip to add another layer, ensuring there are absolutely no microscopic pinholes. This double dipping process is crucial for quality and reliability. As the formers come out of the second dip, they pass through a set of rotating brushes at the base. This is what creates that little ring at the end of the condom. The brushes roll the wet edge of the latex down on itself, forming the bead or rim that helps keep the condom in place. It's such a simple but genius step in the process. After the ring is formed, the condoms, still on their formers, go into a much bigger, hotter oven for the main event: vulcanization. This is where the magic of chemistry happens. The heat activates the chemicals we talked about earlier, cross-linking the rubber molecules. This transforms the weak, sticky latex into the strong, stretchy, and resilient material we know. This curing process is what gives the condom its elasticity, so it can stretch without breaking. It's arguably the most critical step for making sure the condom is strong enough to do its job. Once vulcanized, the condoms are still stuck to their formers. They go through a bath of water and powder, often cornstarch, to make them less tacky. Then powerful jets of water, or air, are used to gently strip the condoms off the formers. They fall into a collection bin, looking more like the finished product, but they're not done yet. Not by a long shot. They are then washed in a machine that's basically a giant washing machine for condoms. This removes any leftover chemicals and powders from the manufacturing process. After washing, they're tumbled dry at this stage. You have a pile of thousands of clean, dry, but unlubricated condoms. Now, for the part that really separates the good manufacturers from the bad, testing, and I mean rigorous, no-joke testing, quality control is absolutely paramount. You can't just hope for the best. First, every single condom produced, 100% of them goes through electronic testing. Each condom is fitted onto a metal mandrel and passed through an electric field. If there's a microscopic hole or a weak spot, the electricity will pass through it, completing a circuit. An alarm goes off, and that condom is immediately rejected and destroyed. Think about that. Every single one. That's millions of condoms a day being individually checked. But it doesn't stop there. On top of the individual electronic testing, a random sample from every single batch is pulled for even more brutal tests. This is where things get kind of crazy. One of the main ones is the water leak test. A worker takes a condom, fills it with a specific amount of water, usually about 300 milliliters, hangs it up, and then rolls it on blotter paper. If any water leaks out, even a tiny drop, the entire batch of thousands of condoms is rejected. Then there's the airburst test. This one is really impressive. They take a condom from the batch and inflate it with air like a long, skinny balloon. According to the World Health Organization and international standards, a standard condom must be able to hold at least 18 liters of air before it bursts. To give you some perspective, that's like inflating a condom to the size of a small watermelon. It's way more pressure than it would ever experience during actual use. This tests the tensile strength and elasticity of the latex. If the sample fails, again, the whole batch is toast. They also do tests to check for visible defects, package integrity, and even the dimensions of the condom. The standards are incredibly high for a reason. Once a batch has passed all these tests, the condoms are ready for the final steps. They're taken to the foiling and lubrication room. Here, machines roll each condom up and drop it into one side of a foil wrapper. At the same time, a precise amount of lubricant is squirted in. The type of lubricant can vary: silicone-based, water-based, with spermicide, without warming, tingling, you name it. The machine then seals the foil packet, pushing out any excess air to create a vacuum seal. This protects the condom from light, air, and physical damage, which is crucial for preserving its integrity until it's ready to be used. Finally, the sealed foils are stamped with an expiration date and a lot number. This lot number is super important. It allows the manufacturer to track the exact batch back to the date it was made, the machines it was on, and the raw materials used. So if a problem is ever found later on, they can trace it back and recall the specific batch. The foils are then packed into their final boxes. The boxes are put into cartons, and the cartons are shipped out to warehouses, clinics, and stores all over the world. So from a tree in Southeast Asia, to a milky liquid through a series of dipped ovens and brutal tests, to a tiny foil packet in your wallet or on a store shelf. The journey of a condom is a testament to incredible precision engineering and an unwavering commitment to quality. It's a process that combines nature, chemistry, and mechanics to create one of the most important and effective public health tools in human history. It's so much more than just a piece of rubber. It's a piece of life-saving technology. Thanks for nerding out with me today on Facts Discoveries. It's pretty mind-blowing, right? If you found this as fascinating as I did, do me a favor and hit that like button and subscribe to the channel so you don't miss our next deep dive. Got an idea for something you want us to explore? Drop it in the comments below. We read all of them. Until next time, stay curious.